When we are working with logs, we just have to remember that it is important to be able to bring them together to a single log, especially when we start doing log equations. So you want to be able to combine as many logs as you have, as long as they have the same base, into a single log. So if you have the addition of two logs, all you're going to do is you're going to take the big number, that's what I always say, and we are going to multiply those together. So our goal is to write it as a single log. So you only want to write the word log one time. The base will never change. So as long as we have a base 4 and a base 4, we're going to end up with a base 4 in our final answer. Then you just take your big numbers 6 and 3, multiply them together, and we get 18. When we are subtracting two logs, you're going to join them together into a single log by division. So when you add, you multiply. When you subtract, you divide. Now, we don't have a base written here, so if you want, you can fill it in as base 10, but anytime you don't see a base, it is assumed to be base 10. So we're going to write down our single log base 10, I'm going to leave it off, of 14 divided by 2, and we get log of 7. So remember, when we are adding, we're going to bring them together with multiplication. When we're subtracting, we're going to bring them together with division. And the same is true to go the opposite direction. Our last property that we have is when we have a constant out in front. So in this case, we've got a 3 times our log, and then we have a 2 times the log. So I always say whatever was in front can flip to the back to be combined. We want to get all of our numbers together. So right now we've got a 3 out in front, and then we've got a 2 in the back. So if we can get everything together to a single value, it's going to be a lot neater and a lot easier to work with. So we've got the addition, so that means that we are going to be multiplying. We want a single log. Both are base 5, so we've got log base 5. If I flip that 3 to the back, what really happens is we have 2 to the third power. If I take my 2 and I use my power property, I'm going to flip it to the back, and what we have is 4 to the second power. So what we end up with is 8 times 16. So because we are joining our two logs with multiplication, we're going to multiply those two together, and we end up with log base 5 of 128. That is our final answer. And then our last problem right here, we've got the same process, it's just we're subtracting. So we've got a 6 and a 2 as our constants out in front. We're going to flip those using our power property. So we're going to have log base 7, and this is the one that everybody wants to write two logs. They want to put a log in the numerator and denominator. We're combining it to a single log, so you only want one log. So we're going to join subtraction with division. We're going to have 10 to the 6 over 1 to the second. Well, 1 to the second is just 1, so really we don't need that. So our final answer is log base 7 of 10 to the 6 gives me 1 million. That is my final answer. Going the opposite way, we've got to look and see, okay, we have a single log base 3 being joined, or we have our single log that was multiplication, x to the 9th times y to the 4th. So we're going to take our multiplication and we're going to go the opposite way. So we're going to undo it, we're going to split that up and expand it with addition. So my log base 3, and if you start looking ahead, we have a power, we've got an exponent, we have two of them. So we're going to use our power property and flip those to the front. So we've got 9 log base 3 of x. We're not going to write multiplication because we're expanding. We're going to write our addition. That 4 is also going to flip to the front, log base 3 of y. And that is our final expansion. We've got division, and we have a power property because I have a little exponent over here. So I know that I'm going to have two logs. We've got 9x, and then we're going to subtract because we're taking 9x divided by y squared. Well, that square is going to flip to the front, so I'm going to have 2 log base 10 of y. And if you look a little further, I didn't even split this all the way because we still have multiplication in this problem. So I'm going to take that and write it as log base 10 of 9 plus log base 10 of x, so I've just split that first term, minus 2 log base 10 of y. So that is as far as we can expand. And then our last problem, we've got multiplication again. So we've got a log base 2. We've got our 8, and that's being multiplied by log base 2 of, that's not going to be a multiplication. It's being multiplied, so we're going to expand with addition of the square root of 5x. And then if you think about square roots, we know that a square root of x is the same thing as x to the 1/2. So I still have a power property going on right here. I just have to take care of that. Nothing I can do to log base 2 of 8, so he's done. I'm going to flip my exponent to the front. This time my exponent's a fraction because we have a root, no different. So log base 2 of 5x. Then I can even split this up a little further because I still have multiplication. So log base 2 of 8 plus my 1/2, and I have to keep this in parentheses because my log of 5x is being split up, but that exponent was on the 5x. So we have to make sure that we don't forget that parenthesis. And there is your final answer.